In this video, we'll be discussing horizontal shifts. So if you would like to do a horizontal shift on your graph, you need to go inside of the function. So you are going to see, if you would like to shift horizontally to the left, you are going to add C units. And I know it seems counterintuitive. So that's the thing you need to remember about horizontal shifts. And anything that we do with the horizontal, it will be kind of the opposite of what you think it should be. So we'll go inside the function and we'll add C. And that will shift horizontally left C units. In your chart of values, this means you need to subtract C from all of your X values. If you would like to move your graph horizontally to the right, you would need to subtract C from all the X values inside of the function. So again, in your chart of values, you would add C. And again, I know it seems counterintuitive, so this is the one that we kind of need to really focus on because I know that I have seen many students mess this up. All right, so if we are given, there's our graph f of x, just that nice little piecewise function. We can start by completing the table of values for f of x, which we did before. So this when we did our vertical shifts. So -3, back to 0, up to +3, back to 0. All right, so this shift right here, f of x minus 2, if we're inside the function, that means we're going 2 units. And again, we're going horizontally, and it's going to be the opposite of what you think it is. It's subtracting 2. That means you're going 2 to the right. Okay, so in your table of values, what that means you need to do is we're not going to deal with the y value this time. Y values only deal with vertical shifts. Horizontal shifts deal with the x values. So the x values, we need to, because we're going to go to shift to the right, we need to add 2 to each of the x values. So for g of x, -4 would become -2. The y value is not going to change because we are not moving this graph up or down. So -2 plus 2 would be 0, 0, 2, 2, 4, 4, 6. All right, so then we would graph these x values. I shouldn't have g of x right there. That should be the x. So we're going to graph these x values, and these will be our y values. So everything is going to get shifted over to. This one's going to get shifted over to. That's going to get shifted over to, that point over to, and that point over to. And then you can draw the graph in. And again, you're not always required to show the chart of values. I just think it's important that you see both when you're learning it, because you need to see both how it's going to look in a chart and again, how to do it on the graph graphically. So that is a horizontal shift 2 units to the right. All right, now let's go back to that funky looking graph we saw in the last video when we did vertical shifts. Okay, we're going to do the same thing here. I need to identify what my shift is, and notice it's inside the graph, right? It's inside the function. So that means we're going to do horizontal shift, and it's going to be 3 units. And again, it does the opposite of the sign that you think. So +3, you would think right, but that's left. You're going to go the opposite of that sign. So again, if we're going 3 to the left, that means every f of x value stays the same because we're not moving it up or down. We're just going to change the x's. So each of the x values, we're going to have brand new x values for our g of x. The y values are going to stay the same, so that's still going to be our y value in the end. But our new x that we're going to use is 3 to the left means you're going to subtract 3 from each of those x values. So this is going to become -9. This is going to become -7. This is going to become -5. This will become -4, this will become -3, and this will become 1. And those f of x values that we had before will also stay the same. So -6 was at 0, -4 was at -4, -2 was at -2, -1 was at 5, 0 we were at 4, and 4 we were at 0. So those, again, we're not moving it up or down, so the y values don't move. We're just going to take the whole graph and shift it 3 units to the left. So this point would go 1, 2, 3, and would be right there. And then this point would go 1, 2, 3, and then this point would go 1, 2, 3, and this point would go 1, 2, 3. Okay, so there's the beginning. So the tail would be here, and then we'd have our parabola looking thing, and then this point would go 1, 2, 3, and this point would go 1, 2, 3. So then our straight line would go that way. So it looks like we took that whole blue graph and just shifted it 3 units to the left, just slid it over. So again, how it looks on the graph versus how it looks in the table of values. You probably won't be expected to do both on every problem, but I think it's good to see it both ways. All right, next example. This one, we don't have a graph, they're just giving us the equation. So g of x equals the absolute value of x plus 1. Okay, so the first thing I note is that my parent function is our absolute value function. And because we're inside, so to get g of x, which is the absolute value of x plus 1, we are inside the function. So that means we are doing left or right, and it's plus 1. So that means we're going to go left 1 unit. So that's what this means when it's on the inside. When it was plus 1 on the outside, we would go up 1 vertically. But when it's inside, we stay there. So if you need to draw your original function, you can. So there's your absolute value function, right? It's just that nice v. We're going to take that whole v and move it 1 unit to the left. So this point would move here, and then every point we would still have that line with a slope of 1, and we'd still have a line with a slope of -1. So again, it just looks like we took the whole v and just slid the whole v left 1. All right, g of x equals x minus 3. Now, this one you might be thinking, hey, wait a minute. This looks just like when we did the vertical shift. And that's the cool thing about this linear one. Our parent function is still this, right? It's still just the straight line. And again, with a going through the origin, has an intercept of 0 and has a slope of 1. So there's your f of x. If I were to move this graph, if I treated it as a horizontal shift, pretended that was inside, then this would be a shift of 3 to the right. So if I took this each point and shifted it 3 to the right, so 1, 2, 3, and then I did my slope of 1, right? Okay, took the whole thing, shifted it that way. Okay, but you might be thinking to yourself, wait a minute, if I look at this and think about it, let me choose a different color. Let me choose pink. Okay, this could also be, yeah, that looks pretty too close to the same. Let's use green. Okay, this looks very similar to what happens if I go down 3. And notice if I take this graph and I go down 3, I end up with exactly the same line. So sometimes, depending on your parent function, the graph might look the same whether we look at it as a horizontal shift or a vertical shift. So that's another thing that you might want to just consider, that you might, two people might look at this and one might see the horizontal shift and some people might see the vertical shift. But notice in the end, you would still get the same graph. So important to know that sometimes these reflections can be a little confusing, so you really have to think about whether you're inside the function or out. All right, so that is horizontal shifts. Come back next time when we talk about reflections.